Hi friends, in this video we will understand the concept of TLS or SSL certificate from a developer mindset. You can find a lot of videos on this TLS or slash SSL concepts on YouTube or any other medium, but my main focus in creating this video was to help a developer, mainly I would say Spring or Java, developer working on Spring or Java application. Developers should have a clear concept clarity. What exactly is this TLS or SSL certificate, and how to resolve any such related errors when developer works on any app tool, says Eclipse or STS. He or she might have encountered PKIX certificate validation exceptions a lot of times when working with HTTPS REST APIs. So let's start and understand this concept. So first of all, let's try to understand what exactly is this certificate, TLS or SSL certificate. So this certificate, think of it like a physical form. Like I am creating a website, I've created a website, and any client coming to my website, he should be able to check my authenticity. Like this is a valid website which I am interacting with, and it is okay for me to publish my any data, like be it a personal data if my website has user form fields. So any client should be able to first get the authenticity of my server, like this is a valid authentic server which I am interacting with. Okay, and how this server proves its authenticity is via the certificate. Okay, so let's say I'm creating a website. I've created a website, and I have a I being a server should produce a valid certificate to all the clients who are coming to my website. Now these certificates are of two types. I am covering these concepts on a very high level. I'm not going on low level details, but yes, I think these high level concepts should be clear at the first step. So let's first talk about this self-signed certificate. So what exactly is this certificate? Same example. I have created my website. I have full control of my server. So any client coming to my website, the first step will be a TLS handshake, wherein my website, my server will publish this certificate. Now this certificate can be created by multiple ways. Let's first talk about this self-signed certificate. In this self-signed certificate, what exactly happens is, so this certificate basically covers two portions. First portion will consider all the metadata information of my server. Like this is the URL, this is the host name, this is the expiry date, this is the duration till which the certificate will be valid. All those metadata details of my server. Second portion is the signature. Like who is signing this who is signing this certificate details? If I am the server, I have created a website, I am the server, I am owning that server. If I am creating that certificate, I am signing that certificate and saying that this information is valid. That means self-signed certificate. Okay. So, okay, let's keep it till this level only. That means a self-signed certificate wherein the server only signs that certificate. Now, no person in this world would consider it as an authentic certificate, because I can't, if I am a user, if you are a user and you are coming to my website and I am presenting this certificate signed by myself only, you will not 100% trust my server. And that's the reason in browsers during development, when you might have seen these scenarios where in the on website during development phase or during local in on local environments, you might have seen this connection is not secure on browser, right? And that's the reason, because during developments the servers are presenting the self-signed certificate. Browser warns the user, like, this certificate is not valid, I am not trusting this certificate. So it's up to you, you want to proceed further or not. And mostly developers click on advanced and proceed further, right? That's fine during development phase. But on production sites, that's the way browser warns user, like, this certificate is not valid, I am not trusting this certificate because it's self-signed. It's up to you if you want to proceed further or not. Okay. Now, what's the other part of it? Like, if a certificate is not signed by the server itself, how can it be converted to a trusted certificate? So on this upper section, so okay, this is a high level snippet of a trusted certificate. So what happens here is, throughout this word, there are a set of organizations which, if those organizations signed any certificate, then all the clients can trust that, like, all the certificates signed by these organizations, root certificate authorities, it indirectly or directly says that the server is authentic. So it's a centralized organization, centralized entities, which signs those certificate and says that these are valid, authentic servers and users can trust these servers. So this is how, on a high level, this TLS or SSL certificates validation happens. So coming to our example, say if a certificate A, okay, before that thing, let's cover out intermediate authorities as well. So if I have created my website, I have to reach that root organization authority to sign my certificate. To distribute that workload, what root certificate authorities have done is they have introduced intermediate authorities, other organizations, and given the power to other organizations, like, you on my behalf can sign these certificates and it will be treated as authentic. So in this example, say certificate A is any server certificate. So this organization, this website is reaching this intermediate authority, like, can you please sign my certificate? So intermediate authority signs his certificate. And intermediate or authority organization, it's also a server. Its certificate will be signed by root certificate. So this thing has already been in place. So root certificate authority, root CAs had already signed intermediate authorities. Like, they have made root CAs already declared that intermediate authorities are authentic servers. And any website, any server reaching out these intermediate authorities and getting their certificate signed will be treated as authentic as well. So this is a 3-layer chain, but these intermediate authorities can be 1, 2, 3, any number of intermediate authorities. So this is a certificate chain basically. Certificate A is a server certificate an application whose certificate is issued and signed by intermediate authority, and intermediate authority's certificate is signed and issued by root CA. So there are, I will show you the content of certificate in a couple of minutes. So basically certificate has all the details, like who is the issuer of this certificate, who is the issuer of a certificate. Issuer for certificate A is B. Who is issuer of certificate B? Issuer certificate B is C. What's the validity? And all those details are there in the certificate. Okay, now let's go to next slide. So this was the example I was talking about. Say I have a website javaminds.com. It's not existing as of now, but yes, let's assume it. It's a server. So any client, any user who is using a browser and he or she invokes like javaminds.com, he enters that in this browser. A lot of TLS handshake is not a one-step process. A lot of request response to and fro communication happens between browser and server. I will show you it in a couple of minutes. But let's first understand this concept on a high level. What exactly happens? So user says, like he enters javaminds.com via DNS resolution, DNS servers. This call reaches my server, reaches this javaminds.com server. Now server presents a certificate. If it's a self-signed certificate, server will present only one certificate. But if it's a trusted certificate, then server will present all the certificates. I'm not going in low level, but on a high level, server will publish all the certificate chains. Like certificate, this is the certificate, it is signed, like this is the certificate, javaminds.com. It is signed by, say, issuer ABC, intermediate authority ABC. And if this ABC, in this example, issuer of this ABC intermediate authority is XYC root CA. So only two certificates this server will present. If this certificate is signed by this and this certificate is signed by JavaMind is signed by ABC and ABC is signed by any ABC1 or ABC2. If three or any more intermediate certificate authorities exist, then JavaMinds, this server will present all those certificate chain to the client, to browser. Okay, and I'm not talking like I don't want to go to that level, like how this chain is presented. So on a high level, the server creates one file, one certificate file. On top, it says JavaMinds. It has the certificate of JavaMinds. On below exists the at second layer exists that certificate which signs that JavaMinds. So all those linked certificate in that hierarchy only exist in that file. So when this certificate chain is presented to browser, so how browser trusts this certificate? Browser has to trust this one, ABC, right? Then only browser can trust this ABC, sorry, javaminds.com. So browser has to trust this certificate ABC to mark the authenticity of this server, like this is a valid server. How this validation happens? So all the browsers, all the operating systems, all the clients, they have this intelligence. They have this intelligence. Intelligence, I would say, is they have inbuilt set of trusted certificates, which means if I go to previous slide, these root CAs. So browsers so let's talk about browser only. Browser in this case will have a list of all the trusted root certificate authorities whatsoever exist in the world. suppose as of today, 100 trusted root CAs exist in the browser, and tomorrow any new certificate or trusted certificate authority comes into picture, then with the browser update, that set of certificates will be updated automatically. Like it will be incremented by one. It will be all the newly created trusted certificate authorities will be added in this list with the browser updates. So if browser trust, like these are the certificate authorities, this is a list of all the authorities. Any certificate which is signed by this trusted authority, browser, how browsers, what's the logic in browsers? Browser says any certificate which is signed by these list of trusted authorities, I will assume it as an authentic server. So in this case, this certificate which is presented by server to browser, so browser starts validating this certificate, javaminds.com. Browser says this certificate is signed by ABC, okay. And ABC is signed by XYC root CA, okay. And XYC root CA, this certificate exists in my repository, and I trust this certificate. If browser trusts this certificate, that means browser trusts this certificate as well. And browser trusts this certificate as well. So this linking happens via this root CAs. So this logic exists in browser. Browser says, I am trusting this XYC root CA certificate, which means I can trust this one, ABC certificate, which means I can trust javaminds.com. So browser on the URL bar, you can see a green padlock button like HTTPS secure site. Browser says this site is secure, the server is secure, and user can share data with the server safely. It will be an encrypted data. Whatsoever data will be shared with the server, and from the server, it will be all authentic encrypted data. So this is how a TLS handshake happens. So this certificate sharing and validation of certificate is one of the steps in this whole TLS handshake process. So it's a multi-step process. A lot of other steps comes into picture after this certificate validation. I will not cover those steps in this video. Probably I will create another video for it, but on a high level, I will tell you what exactly happens in those steps is what will be the encryption logic which client and server decides. So server will say that I can share like these are the 5 or 6 encryption logics which I support, and client says, okay, let me choose any one of these one. And those encryption logic, all those security level setting, configuration settings happens in further steps. But the main point I want to highlight in this slide is how a browser or a client trusts this server is via this chain of certificates and the root certificate repository that exists in browser. Now coming to the next slide. Okay, so I'm just covering slides information as of now. I will show you all these details after this slide. But first, let's discuss the concepts here from a developer mindset. My main aim to create this video is the developer should be clear in the concepts. She or she should have clear concepts what exactly happens behind the scenes. So this slide basically specifically covers the Java application process, how the certificate validation happens. Because I mean, whenever if a developer is creating any REST API, he is using any other REST API which is HTTP, which is a secure REST API, HTTPS. Then 99.9% developer might have encountered this PKIX validation exception, like this certificate is not present, though that exception. So the same steps happens, all those steps, TLS handshake steps happens here as well. Say developer is working on an application and he or she has to interact with this server javamines.com. Let's say they're using this template and calling this server API via HTTPS protocol. Then the server will, same steps, server will present the certificate, and at the very first step an exception will happen, like PKIX validation exception, this certificate not found. So what happens is, like browser has its own repo, Java JRE, Java runtime, also has its own repo of trusted certificates. So what is this file? Is CA certs file. This is the location of this file, CA certs file. It is a collection of all the trusted root certificate authorities, root CAs, root certificates. And all those certificates which are signed by these root CAs, Java JRE trust those certificates as well. Same concept, same concept. The only difference is the location is different in browser. Browser has a different algo, a different concept, a different folder. The folder for the Java application is this one. Like this is, I would add the snippet as well, CA certs. This is the location. So the point comes, next point which comes is, what about other applications like Node.js applications? What about other applications written in other different languages? So all those have their different trust rows. So the concept here is this file, the trust store file, any file which has a root CAs. To resolve this error, if I talk about this particular case, to resolve this case, what usually developers do is they import this certificate. They go to the site javamines.com, they download the certificate from browser and import that certificate in this file, CA certs. So if this javamines.com certificate is existing in this CA certs file, it means that Java application is directly saying that this server is authentic because I am trusting this certificate, right? This is how it happens on local. So we have made Java to come to the point that trust this certificate. This is a trusted certificate which exists in CA certs file. So trust this certificate. You have to trust it, right? This is how on development phase we usually do. But there are a lot of ways to handle this scenario. But I am just talking about this generic concept here, which mostly we follow. Okay, so now a lot of theory covered. Now let's come to practical. Let me go to the browser. Sorry, I had to took a short break. Okay, so let's first check So there are a couple of sites which exist and they give the whole certificate information. So I'm just Googled it, SSL certificate checker. So let's try any site, say SSL checker. Okay, so let's enter, say, google.com. So it has given all the details of the certificate, like google.com resolves to this IP, this is the server IP, and this is a trusted certificate, and this is the expiry, the host name. I'm not covering these details, but the main point I want to highlight here is the certificate chain. Like this Google certificate is issued by and issued or signed by GTS CA1C3. Now this second certificate comes, this one GTS CA1C3. So this certificate is signed by GTS root R1. And this certificate is signed by Global Sign Root CA. So when I enter google.com, so if I go to this padlock, connection is secure, how this browser has trusted this certificate, let's explore that thing. So if I go to connection is secure, I click this one, certificate is valid, click on this certificate. Okay, so this is the certificate details. This certificate, Google certificate issued by GTA, we have seen. Go to certification path. So this is the path. Like this certificate is signed by this GTS 1C3. This certificate is signed by R1, and this certificate is signed by Global Sign Root CA. Right? We have seen this thing. Global Sign Root CA. Now, who trusts this Global Sign Root CA? Let's check this out. If I go to browser settings, privacy, security, manage certificates. Okay. Let's go to trusted root certificate authorities. So these are all the trusted root CAs which Chrome understands. Chrome says that these are the trusted certificates I trust. So what was the certificate name? Global Sign, right? Let's go to Global Sign. Here it is. Global Sign root CA. See, so these root CAs are self-signed certificates. So you see, issued to Global Sign root CA, issued by Global Sign root CA, issued to and issued by. These are same. So that means these are self-signed certificates. And these are trusted entities. Okay. So all those certificates signed in by these certificates will be trusted one. So Global Sign root CA, this is the certificate which we have seen for google.com, the last certificate, right? Global Sign root CA. So this was the last certificate in the chain, and this certificate Chrome understands. Chrome says that this is a trusted certificate which I understood. So indirectly, google.com is a trusted certificate, trusted server. So let's talk about, say, let's go to instagram.com. Let's go to padlock, connection is secure, certificate is valid, certification path is DigiCert High Assurance. This is the chain of certificate, DigiCert High Assurance. Let's go to that. Let's check this trusted certificate. DigiCert High Assurance. Here it is. DigiCert High Assurance. Okay. So this was the root. This is the chain of certificates, and this is how the trust happens. So now let's explore this certificate. Let's explore any certificate, like details of the certificate of Instagram. See, these are the basic issue. Issuer is this, right? This is validity, valid from, valid to, CN, subject name is this. I am not covering those concepts in this video, like the certificate details concepts. But my main point was to show you the chain of certificates, how the trust happens. Okay. Now let's see the certificate CSRs file in Java as well. Like, let's go to this folder, program files, Java, JDK, lib, security. So this is the CSRs file. So there are commands to get to see the contents of the CSRs file. You can find it in Google. I'm not covering those commands here, but the main this file I want to show you. Like this is the file where you can add these trust certificates on local during development phase. Okay. And the other thing is, I told you like TLS handshake. A lot of steps happen in their TLS handshake. Like certificates are presented, all those things happen. Let's see those things. So these packets, whatsoever requests, whatsoever handshake, all the requests to and fro requests happens in between Instagram.com and its server. This client, this browser and server. This we can't see in the console here. Like if I go to inspect and go to network, I can just see the basic requests information here. Like these are the requests, right? I can't see the packet, whatsoever packets have exchanged. What was the encryption that was decided by the server? So I will just cover the high level details. I'm not going in low level and clarifying those concepts here, but just want to show you high level details of the how the TLS handshake, what are the steps involved in TLS handshake. So this I think is the server remote address of this Instagram.com. So there is a tool called Wireshark.com. A lot of tools exist, but I will show you it via Wireshark. So this Wireshark.com, it basically captures all the packets. So I am selecting the Wi-Fi here, Wi-Fi connection, and packets. Okay, the packets have started capturing. So let me reload this page. Reload the page and let me pause it. Stop capturing the packets. Okay. Now it says destination address, source address, all those packets information, all this source and destination server exchange, whatsoever information has been exchanged between these IPs, all the packets has been captured. So what was the IP of Instagram.com? Remote address IP is 174, ending in 174. Control C. Let me apply a filter here. Sorry. Apply IP address. Let me enter Instagram IP, server IP address and enter. Okay. So it will show me all the packets where this IP is in source or destination. Okay. So let's go to the end. Like this, I mean, see, a lot of to and fro communication has happened between my local 1.5, my local system, and this Instagram IP, Instagram server. Let me expand any such packet here. Let's see. I will not cover these details, but so these are all encrypted details here. But my point here is it's not a one-step process. A lot of to and fro communication happens. Like see, I went to the down, but the initial TLS handshake happens at first step only. So this 1.5 is my local. It has initiated the handshake. The browser has initiated the handshake with this, with this server. Like the handshake happens. The data exchange, whatsoever has happened, it's all encrypted data. It is not because it's a HTTPS protocol, so all these data are encrypted one. So not covering these details here, but yes. So the main point here is it's a multi-step process. The TLS handshake, it's not a one-step process here. So the cipher suits are presented. Whatever cipher suits have to select the browser and server. The what encryption has to be followed for all the further communications, how the public keys will be shared in this TLS handshake only. Okay, I think this one is we have also covered. and we have also seen the CA certs file. I think this video, this is pretty much the content I want to cover. I think I am able to give a high level view of this concept of TLS handshake, TLS certificates. I will try to cover any topic which is left, which I think will be more. I mean, I should present it. I will create another video for it. But yes, my main aim, which I intended before creating this video, I think that aim I have fulfilled. All those details were in my mind from the last couple of days. I just wanted to create a video and present it with you all. That's it. Thank you. Thanks for your time. Thank you for seeing this video. Thanks.